Welcome to EDU World Space.
In this problem on periodic motion, we are told that we have two springs with the same unstretched length, but different force constants, K1 and K2, and they are attached to a block with a mass m on a level frictionless surface. We are asked to calculate the effective force constant in three situations, A, B, and C. We are then asked to determine the ratio of F2 over F1, the frequency of oscillations, if the spring is cut in half and the same mass is suspended from one of the halves. So firstly, we let F1 equal to minus K1 delta X1 and F2 equal to minus K2 delta X2. So we assume that in each situation, the mass moves a distance delta X. Now, in part A, delta X is equal to delta X1, and this is the same for spring 2, delta X2. And so, therefore, the force F is equal to F1 plus F2 simply. And so we can write this as minus K1 plus K2 times the distance that the spring stretches, delta X. So we can see, therefore, that the effective spring constant K EFF is simply K1 plus K2 in this situation. Now for part B, despite the orientation of the springs and the fact that one will be compressed while the other is extended, we'll have delta X is equal to delta X1 minus delta X2. And both the spring forces are in the same direction. So the above result for A is still valid. We have that the effective spring constant K is again K1 plus K2. Now for part C, if we have massless springs, the force on the block must be equal to the tension in any point of the spring combination. So the force F is equal to F1, and this is equal to F2. And so delta X1 is equal to minus F over K1, and similarly delta X2 is equal to minus F over K2. And therefore, delta X is equal to minus 1 over K1 plus 1 over K2 times F. And this can be written as minus K1 plus K2 over K1 times K2 times F. So we can simply see that the effective spring constant K effective from here is simply K1 K2 over K1 plus K2, and that's the answer for part C. Now for part D, we have that the result here in part C shows that when the spring is cut in half, the effective spring constant then doubles. And so the frequency increases by a factor of √2. So F2 over F1 is equal to the square root of 2.